Okay, now let's build up a complete dual graph. So uh, we have our guide here, like a configuration that sort of tells us how this is going to look around the red icovertex. So we'll follow this, um, and we can sort of choose like how far to extend, like how big of a chunk of these hex grids to use. Um, but let's see. Okay, and also this hex pattern here, this is this is sort of specific for the red for the red vertex here, red icovertex here, blue icovertex here, and yellow icovertex here. So this is going to go into this triangle, and then this triangle is going to, yeah, this whole hex pattern is going to map into the triangle down here. Okay, and now let's choose. This is going to be the red icovertex, and then this we'll use this blue dot the as the blue icovertex. So now our Goldberg numbers are going to be 1, 2, 3, 4, 5, 6, 7 steps, uh, and then turn right and move 1 step. So this is 7, 1. And this is the one I posted before. That's like the radius 5 sphere. So let's see if we can recreate it real quick. Okay, so we just want these colors in a row. So I'll start with that. It's got yellow, cyan, purple, orange, blue, green, red. Oh, and we already moved the red one out of the way. Yeah, this yeah, you can see this green one should bump into the red one, and then we turn right and go blue. So let me shift these over. And yeah, it's a little bit disorienting. When you move one, they all sort of move. Uh, but yeah, I sort of adjust them a little bit, and yeah, it's the idea is that in here, these 8 vertices are in a line, and also on here they should sort of be in a line, and the line is sort of tilted up so that uh, yeah, because over here the blue icovertex is on the next row, so this the row that the red one is on, it sort of has to tilt up a bit so that the blue icovertex is on the row below it. Um, okay, and now we only specified the colors here, but we can sort of do a sanity check and make sure that the colors on the next row match um, what we see, and they do. So that's good. Um, okay, and maybe I'll even start drawing in vertices just to, yeah, because why not? Um, okay, and now, okay, I'll move the stray vertex here so I can reassign the color. Okay, now we got uh, orange, blue, green, red, yellow. So I'm just looking at the second row and copied it in. And let's add all the vertices for the honeycomb pattern. Okay, and now the next row after that, red, yellow, cyan, purple, orange. So great, that's what we expected. Um, okay, now we've got the whole uh, grid made. And there's some problems. You can see that this orange vertex has two cyan vertices next to each other, uh, but so far this sphere simulator doesn't. It'll let you simulate it, but um, yeah. So I just switch to this view. Um, yeah. So this is just taking the dual graph, uh, and then and then shifting the points around to fix the violations. And you can sort of see, yeah, these two, there's two separate vertices here and they're trying to collapse. And that's, yeah, that's a consequence of this orange guy having two CN1s. So, yeah, two CN neighbors. Okay, so that's not going to work. And so let's just remove this edge and see if we get something better. And okay, and that seems to be resolved. Oh yeah, and then our, yeah, and this is sort of the red row that we initially added, and here's the blue, the row below it, and they don't, yeah, there's a conflict here, and yeah, it's easier to see in the dual graph, I think. Yeah, so this, so both the orange and this yellow one have two purple neighbors, which is bad, and we can just remove this edge, and by symmetry this edge got removed as well. So now I think if we redo the graph, then it should just work, and we can see the error is 4 times 10 to the negative 14th. So there's negligible error. So this completely works. And yeah, let's try to bump up the radius 5.1. So we get some error, but it goes away as the vertices get adjusted. 5.2, and this is sort of close to working, but no, not quite. Yeah, there's a lot of errors. Yeah, it's sort of hard to interpret all these length violations, but yeah, if I move it back to 5.1, the errors are gone. 5.11. Yeah, it's not completely clear yet that it works, but you can see the errors rapidly decreasing. And the violations aren't drawn if they're like, it's only if they're like off by, if the violation's by 0.00001 or more. Okay, and now the errors like clearly getting pretty minuscule. So 5.11 works, and you can sort of work through all the radiuses. Okay, and then on the lower side, let's decrease the radius, 4.5. Yeah, so the graph gets scrunched a bit, but yeah, eventually I think this one works. And if you go way too low, then it won't. Yeah, it's just hopeless. Yeah, it looks like it stopped even adjusting vertices. It reached some equilibrium, but it's an error. Okay, that's it for this video.